Yeah. So, any third person? Hello.
Hey, hi. How are you?
Hi. So nice to see you. Is this your first time here?
Yeah, first time here.
Okay, nice.
I tried to join before, but I couldn't. Having some business conflict.
Okay, no problem. Welcome, and we have a fourth person as well. So, I am the organizer. Krishnan is a regular here. We have been doing this for now close to, I think, 2 months. I think 2 to 3 months. So, the way it works is, this is basically a Python programming online session. This is not me teaching. This is people bringing their problems, and we just interactively solve. So, we are currently working on a PV dataset which we got from Kaggle. So to begin with, I'm not sure if you are aware that all these sessions are recorded and the recordings are put up on YouTube. So if you want to know the background for this, you can just go to my YouTube channel and check it out. So do you know about this?
No, I was not aware, but I'm okay with that.
Okay, so yeah, so I can just put it up on the chat. I don't see the chat is here. So
yeah, below.
You can just look for Python Power Electronics on YouTube. So I'm just writing it on the chat. You can have a look. This is the name of the channel. And there is inside that there is Learn Python Online, and this is the name of the playlist. So this contains just about every recording in this entire series. So I can maybe just actually give you the link. That would be better.
Are you sharing? Because I'm not seeing anything. I'm just seeing the camera.
No, you have
to.
So
on the below, there is a bar where you have several bar items like mute audio, stop video, share screen, and then next one you have the chat. On that, if you click, you should see the messages that he's typing.
Oh, okay. So yeah, I got it. Yeah. Go ahead.
So now you should be able to see it. That is the last link is the YouTube playlist. So this has all the recordings, not just of this series, but also of another series which I did before this when the COVID lockdown started. So that has a lot of basics of Python. So I'm just asking, like, what is your level of Python programming?
Well, I'm a new to Python, and let's say this started as a hobby with this in the COVID. So that's how it started, I think, with the Python. And I have been studying. So my background is I'm an electrical engineer, and nice. I did software, but I was more focused on hardware, and I'm more on the telecommunication. This started, and my objective is more at this moment still on its house automation. So I do not have it professional, let's say, planning at this moment. Maybe soon, let's say, if I have it doing some little project, maybe this can evolve something more professional.
Okay. So we have two more people. Harish is here, and we have one more, Krupa. Can you hear us?
Yes, I can hear you.
Okay. So welcome to this session, and just say, I don't know, this is probably your first time here?
Yes, it is. I have been interacting with your with Python Power Electronics, and I do have some questions from what I've been working on, and yeah, I thought maybe it would be a great session to inform me and the way forward.
Okay, sure. Okay. So the way it works is, like I said, we don't have any fixed agenda. People, you can bring on your problems. For now, we are working on a PV dataset which we found from Kaggle, and we are trying to do a linear regression model on it. So we can either start with that, or if anyone has any questions, I'll be happy to answer them before we get started. Either way.
I just put the Kaggle link for the dataset that we had been working on the last few weeks. So in case anybody wants to check that, it's there on the chat link.
Okay, so I think since there is no question as of now, we can get started. So Krishnan, maybe, I don't know, if you want to share your screen?
Yeah, I will start. So maybe what I will do is like I did last time, I'll just quickly also brief what is there, what we have been doing. So I'll just share the screen and then do that. So you see my screen now?
Yeah.
Yes. Yeah. Okay. So yeah. So this is a dataset about PV forecasting in a microgrid. It was not just PV but also a load forecasting paper where they had a microgrid in Belgium, in Liège, and they wanted to predict what will be the PV generation of that place as well as the load in the microgrid. Using the weather data as well as the data past measurement data.
Okay, can I just quickly, I'll give like a 2-minute overview so that we can then keep going with this. So, like what Krishnan was saying was that this is like a PV forecasting dataset from a place in Belgium, and what they have done is they have collected weather data, and they have actually collected PV data and load data. Now, what they're trying to do is they are trying to use a neural network method, which is like recursive neural networks, in order to be able to predict their PV data and also predict the load. So they are now comparing it with what they have actually predicted, forecasted with respect to what is actually measured. So now what we have done over, I think, probably 4 or 5 weeks is that we actually took all the data sets that we could find. Actually, it's not just one Excel sheet or rather CSV sheets. It is several of them. So we collected all of them. We collected data which related only to weather. We collected data related to the PV. We collected data related to PV forecasting. And we cleaned the data to begin with. For example, we managed to extract data within a single common time period for which data was available in all the sheets. We then extracted data and created one single data set where the PV measured data is available in one column, and we have all the other weather data in the other column. So now we made a decision as to which weather data we should exclude and which weather data we should include. So since we are talking about PV, we decided to include things like solar irradiation, temperature, and cloud cover and things like that, because these will affect the PV forecasting. But we decided to exclude things like wind speed and things like that because we said that they should not have that much of an impact on PV production. So with this, if you can scroll all the way at the bottom. So eventually we came on this data set. So for example, if you go scroll up a little, you will see that the data set is this one. So this is what we said will be a final data set. You see the first column is the PV, which is the actual PV produced. The others are data which is related to weather. Now, what we are going to attempt to do, right, and this is what I'm saying is an attempt, because remember, to be able to forecast something like PV from weather, you need a very rigorous artificial intelligence model. We are not going there yet. That's quite complicated. It requires also a rigorous mathematical background. But what we're going to try to do is we're going to use the remaining columns, that is the second, third, fourth, and so on, and try to predict what would be the PV. So we are going to use, the first step we are going to try to use is what is called as linear regression. So linear regression basically is that you are trying to fit a straight line. So it's like similar to what you're saying is y is equal to mx plus c. In this case, since you have several variables, you are going to have y is equal to m1 x1 plus m2 x2 plus m3 x3 and so on and so forth plus some c. And the idea is to be able to find all those coefficients, right? So with this, what we had actually also started off with, we had started off with going through the linear regression function, and we had seen that the linear regression function consists of a few things. For example, in any machine learning model, we will need to have a training data set and a testing data set. So this data that we have, we are going to first split it into two parts. One is a training data set on which we are going to train our model, and then with that model we are going to test it on the remaining data, which is called as a testing data set, right? So this is where we had left off. So just a quick stop, and does anyone need any additional information at this point of time? So I guess, Krishnan, with this we can go over to once again the linear regression page. You can Google it.
Yeah, it was in scikit-learn, right?
Yeah, scikit-learn.
Okay, so I think we'll go back.
Yeah, linear model, and within that there will be linear regression.
Yeah, logistic linear regression. Yeah.
So linear regression, it is very unlikely to begin with that we will actually be able to create an accurate model based on linear regression, because because something like PV is fairly non-linear, and it is tough to predict something like PV with a linear model. But it's still a great way to get started with machine learning, because linear is something which everyone more or less understands. So to get started, you see what this is. Like, for example, you see that this is called class sklearn linear model regression. So the way it works is sklearn or scikit-learn is this huge package for machine learning which is available with Python. There are other packages also like PyTorch, and I think maybe a few others, but PyTorch and scikit-learn are the most popular. So scikit-learn is the parent package, and within that there are several. So for example, you see linear model is one of them, right? So since linear regression is within the linear model, this linear regression is again within the parent of linear model. So linear regression is a class, right? So here, if you look, when you start off with, we are going to call this linear regression class, and we are going to create a linear regression object, right? So if you come through this, we went through some of these before. It is just that some of them are true, like for example fit intercept. And fit intercept basically means, do you want a y-intercept? That is, in any line you have y is equal to mx plus c. Do you want that y-intercept c? And the answer usually is yes. So, and the default is true. Now, besides this, what we had started looking at is, before we start to do this, we need to be able to create a test and train data set. So for that, you can again start a new page and search for test train split.
Yeah, is it in sklearn?
I think it is in sklearn. It is in sklearn. Could be train test, yeah, train test split, yeah. Okay. So this is where we start off. So the idea again is this. Basically, you have data. So let's say, for example, any data that you have, let's say you have 100,000 rows of data. Now, whenever you have data, you use the data to create a machine learning model. That's how it usually is. Now, when you create a model, it is also important that you test it. So you do not use all the data for training, because if you use all the data for training, there is no way to test it, right? So this is where you do a train test split. The reason why you use this function is that this function randomly picks out rows rather than picking out rows sequentially. For example, if we were to split it ourselves, we would split the data sequentially. Like we might choose, if out of 100,000 rows, we choose to use 20,000 rows for testing, we would choose the first 20,000 rows, or maybe we would choose the last 20,000 rows. But if a human chooses, there is a potential that they will choose a sequential number of rows which will introduce bias. So train test split avoids that bias, right? So if you look, these are the parameters. The first is the arrays, right? So if you come down again, there will be some examples. So these are some examples. So for example, the train test split takes, if you see, two arguments, x comma y, right? So x is the input, y is the output. The test size is the ratio, it is between 0 and 1, right? So basically 0.33 means the test size is 33% of the total data size. Random state is something very different. That is when you want to have a consistent random state among all your machine learning models, but you can leave that out. But once you have this, it will return these four objects: xtrain, xtest, ytrain, ytest, right? So this is what we will do in this particular lecture onwards. So I'll just stop for a minute. Does anyone have any doubt?
Just one quick question. Can we block select them or something like that? Because I think we started this question last time. I'm not sure if we did, but because we want to be sure that we have the entire day captured together, or we don't want all the night data to go in the training set.
I would
should not be a.
Yeah. I would say that because you use train test split, the chances of that happening are lesser. That is the idea, because it is a random plucking. So I would say that is one of the reasons why it is advisable to use train test split, because then it will ensure that there is data from different parts rather than just maybe only day data or only night data or something like that.
Okay.
Yeah. So what we can do is we can get started with trying to do this with ourselves. So first thing we need to do is, have we imported sklearn?
Just a second. No, I don't think so. I think I have to run this code because it's been a while.
Okay.
I went over last week. We missed it, so I'll probably have to run this code. I remembered just now.
That's okay.
Yeah. So, and probably we don't have to run everything, but at least a few of them. I realized it quite late. So, we hadn't downloaded sklearn. We'll have to do that as well.
Yeah. So, yeah, we can do that.
I'm sorry, I'm doing it one by one, running it one by one, because some of them are not required, but moreover, some of them are quite, could be making mess of things. So, just taking a bit of time to do this. Okay, this is going to take time, because this is why I wanted to be sure what I'm doing here, because this applying the time proc is going to take a bit of time, where we modify the synchronization. Okay, it's done. Now it should be
fine. Okay, great. Actually, oh my god, it was.
What happened?
because now we have to install scikit-learn, so we might have to switch off.
No, I'm sorry. You mean to say install? No, it is installed.
It is installed. Very good. Okay.
No. I thought. I mean, it is from Anaconda. It's through Anaconda, so it's scikit-learn is there.
Okay.
So I was thinking that I have imported or yes, it's not imported, but yes, it is installed. I have both Anaconda and non-Anaconda version on my PC. So this one is Anaconda version. So it should have the. Okay. So we'll just say.
Yeah. So you have to go over to that. You can check out that scikit-learn page, test train, and that will tell you exactly what the import will be. Okay.
So this one is test train split.
Yeah, test train tester.
Yeah. Import. So we'll just do this. This will be fine.
Yeah, that's it.
Yeah.
Okay. Great.
So I will just do a quick show of the data again, so that. Oops. Sorry. Oh, sorry. What is this data? Data is here. So this is the data that we have, and it's actually of size 2784 rows. It is every new underscore new. So it has 2784 rows, which is I think should be something like 29 days. There is a sample per every 15 minutes, and so we have 29 days of data, and so we can try to do this test train split on this, right?
Yeah. So to begin with, if you see, we have just 2,700 rows. That's not a lot to begin with. So typically when you train any machine learning model, you're looking at least hundreds of thousands of lines of data, at least. Typically you would, for more complex systems, you would need millions or even billions of data. But so what we have is actually very small. Very small.
Yeah.
But anyway.
Yeah, in fact, I think they have just given the data where they are showing how good is the performance of the neural network. They are not showing the data where they trained the neural network.
Yeah. I mean, that actually, because a lot of it will also be data that they cannot disclose and for things like that. So, exactly. So, anyway, that's never mind. Because what we're trying to do here is to learn how to use the commands. You can pick up your own project and continue later.
Yeah.
So,
and just for those who want this code, I had sent the previous version in the Google groups. And if we make progress, I will send this new version of it also in the Google groups. Yeah, go on.
Okay. So what we have to do is, this data frame that we have, we need to first extract two variables out of this, the input and the output, right? Now the input we know, or rather the output we know, is the first column, that is PV, right? The inputs are all the other columns, right? So now the question is, how are we going to do this? What are we going to do? If you go back to the test train split, you'll see that what it expects is NumPy arrays, right? It expects NumPy, that is, expects X and Y to be NumPy arrays. So the first thing what we need to do is, let's say for example, you pick out the PV row. So for example, if you go to the data frame and you call Y, that is your output, so denote it as Y, Actually, you have to scroll down because I think the screen is a little small.
Yeah, I see. Is it better now?
Yeah, now we can see.
Okay, I will just create a few more
Yeah.
Now is this better, I guess.
Yeah. Okay. So if you look at this, if you extract the PV column, this is your Y, right? This is the output.
Yeah, okay. And this will be PV, right?
Yeah. So now if you look at what Y is, it will be a series. So you see, it is a series. Now, what is important is you can always convert these, because see, remember that pandas, series and data frames are built on NumPy arrays. So the NumPy array is the base, over that is a series, over that is a data frame. So therefore, if you have a series, you can convert it to a data frame. So what I would suggest is just open another tab in the browser and just Google converting pandas series to NumPy array. And this is like a common problem, so I think it will be the first stack over there. Series.
They already have it in PyData also.
That's also fine. Yeah.
There's two NumPy.
So you can just scroll down. There will be an example. Mostly you just have to pick it out. So it should be, yeah. See here. Yeah. So series to NumPy, you get an array. So what you can do is you can just say Y is equal to Y dot to NumPy. So basically you don't have to create a new variable.
Or I can just say here.
Yeah, that's also fine.
Not sure why it's not working. Let's see. Yeah, let me see what is Y now. Y is an array now.
So now this way we have now got Y as an array. Now the next step we have to do is we need to now extract all the other columns, right? So there's two ways you can do this. Either you can create another data frame, that is X, and specify manually each column, or what you can do is you can use the same data frame, the entire data frame, make a copy of it and drop the PV column. So that is simpler. So you can just say X is equal to dfpv. Only thing is you have to create a copy. So just say dot copy, because otherwise you will be using, no, first say copy, don't drop anything. No, do not drop, because otherwise you'll lose it. So make a copy. You say copy and
what do you mean?
Dot copy. It's called dot copy, and there's a method. Yeah, it's a method. So yeah.
And then you want.
Yeah. So now you can just say drop. Yeah. So again, you can just do Shift Tab. If in doubt, just do Shift Tab always. Yeah. So you see. And
okay, just a second, I will go down a bit. Yeah, it's not coming. Okay.
Yeah, so you see columns. So you just say columns is equal to and just say PV. And the only thing is you have to say in place is equal to true.
Yeah, that's what I thought here also. If you don't do in place, it will just do a copy on X, right? In the previous line.
Yes, that is a good point actually. You didn't have to. Yeah, that's a good idea. It'll return another data frame. I would still say be careful, because it's an important thing.
Yeah.
Only thing is you have to say in place is equal to true, because this will otherwise not happen. It's another data frame.
Yeah.
Okay. So now check out X.
So,
and now you can do to NumPy here as well. You can.
There is one question I have. This is going to be confused, because I think the time and date, not day, but the time is also one of the inputs. So would that also be going into the NumPy array? I don't think so.
Why is the time an input?
because the time of the day also is important to predict the solar PV generation, right? Because the other factors are also important, but time of the day also, okay, you can say that the time of the day indirectly affects some other factors, but whatever other factors are, like cloud cover and all the others, if it is at midnight, we know that there's no PV possible.
The reason why I would, the problem with that is now this time data, if you look, for example, in the middle of the night, that the fact that the PV will not be generating anything will also be decided by all the other factors. For example, the temperature, everything else. The only thing is, do we have solar incident radiation? Do we have...
Yes. I think SWT is there. I think, just a second, I'll go up and quickly check that. I forgot the abbreviations. I think horizontal irradiance is there. SWT. Yeah, I think then that should be...
That's it. So, because otherwise the problem...
SWT top is also there. I think SWT top is also there. So, both should be fine. I think both of them are there here.
So that would be, exactly. That would be better. It would be better to use that rather than time data, because time data is typically a little difficult to handle, because now what will happen is you will have to convert it to the milliseconds from epoch. So it's a bit of a mess. But anyway, you could if you need to.
Okay. Yeah. No, I mean, you can do a few things, but I understand, because for instance, one of the problems we might face is that if we introduce time, we have to also find a way to make sure that 0000 is close to 2359.
Exactly.
It has to be a circular thing. It's a problem. But the other thing, the problem that I mentioned might also no more be there, because earlier I was saying maybe we need a block of data because we don't want night and day to be messed up. But once you remove time completely, that will not happen.
Yeah.
So that's a good thing. Yeah. So it's just x dot numpy. This is what we know, right?
Actually, just cast it back to x. Yeah. So, or you can put the 2 numpy. Yeah.
Okay. So
now that we have this, the next thing what we got to do is you can actually just go over to that test train split page and just copy it, because instead of you can just copy that command. It's just that they have this series of how it is to be done, so you can just copy one example. Yeah, that's it.
Okay.
So you can pick out that one.
Okay. Oh, you mean to say the...
Yeah, just make typing a little easy. You can remove the random state. Yeah. I mean, if you want to type, you can type, but...
Okay, yeah. I think I have to
change
specify
x.
Small x.
Exactly. And remove the random state, because...
Probably test size I will make 0.2 maybe. There's not a lot of data. So maybe even less, 0.1 I'll make it.
Yeah, no problem.
3 days of data should be enough. Random state I'll remove.
Yeah.
I think 42 they have specifically mentioned 42.
Yeah.
Because of the Hitchhiker's Guide to Galaxy.
Yeah. Okay. So this is what you're going to do. So you see X train. Just check out what is X train. How does it look? X train, Y train.
Yeah, it's I will check the size perhaps.
Oh, wait. What is that thing?
Dot
size. It's X train dot size. So it's a method on that. Okay. I think what we have to do. We have to do a little bit of cleaning. So if you look at X train again.
Yeah, there's some problem. There's some things.
So why is
202? And X train cannot be this big also. There's something wrong.
Yeah,
because we just have a small data set. I mean, X train is bigger than X. So, oh no, this is 16,000. Okay. I think it's. I think I should type shape. Okay, let's say.
Okay.
X train dot shape should be 2505 and 6. Okay. Yeah, so there is probably some cleaning that has to be done.
Okay, so can you check out once again, yeah, what is Xstring? Just look at Xstring and let us try to compare it with the data frame.
You mean Xstring?
Yeah, so if you see 0, it's 1, 2, 3, it's the fourth column. So if you look at the data frame, that is DFPG weather new, and just do ahead on that. Actually, you can try a new column so that you have this.
So it should be fourth from here. 1, 2, 3, 4. This is SW top, SWDT top.
Okay. So can you look at that column specifically and just do a unique on it?
SWT.
Actually, that's the string.
Oh, sorry. Within.
Okay, do n unique.
Sorry?
N unique. So you know the number of unique values. So the first problem you see that D type.
That is something else.
No, it's a method. These are methods actually.
Okay, that's why maybe unique also have to do methods.
So there is a problem. You see here the D type is object.
It's not a
string. So what we have to do is we have to convert this into a number. So what we have to do, again, we can write a pandas function. So the usual thing, I think we already have that function. I don't know if you want to go and copy it or something, or you want to just quickly write it, however you want to do it.
Which one? This, we had a time proc, something like that.
Yeah. But you can, I mean...
Redo it, I'll redo it.
Yeah.
So
just say num to float or string to float, str to float. And you have to take an x. So what we are going to say is, here what we are going to do, see basically you can say try.
Sir, I have a small doubt.
Oh yes, go ahead.
Yeah, what happened to SWD top, sir? Why we are doing this? Still, like, is it a text or numbered one?
That is the problem. You see here, it is becoming a text. See, if you see the D type is called object. So the way it works is that if it was a float, it would be NP float 64. Instead, it is.
I will probably check other variables and see if we are giving it correctly. Let's say td dot unique. Yeah, it's not saying D type anything, but I think it says an array.
Yeah, but if this is the case, then because by default all of them are float 64. So if nothing is specified, then the D type is. So for example, to this you can just say dot D type, or you can say type of this, and yeah, just type. I'm not sure what it is. Try dot D type.
Okay, that's fine. Type try. Oh, yeah. Sorry, D type is better, I think.
Yeah. So this okay. So this is the thing. So by default it is float 64, but if it sees any mixture, it will cast everything as a string.
Yeah. So this one is O.
Yeah.
So perhaps we have to just quickly see. I just want to quickly see if somebody else is also not. Is what describe is it? Or info, what is it?
Yeah, one of those, yeah. Info.
Yeah, so this is the only one. The SWT top is the only one which is object. Yeah. Others are either int or float, so they are fine. The only problem is with the SWT top.
Yeah. So what we can do is, we can just, in that try thing, what we have to say is, we try to cast it as a float. So we just say try colon. So basically when you say try colon, whatever you're doing here, you are trying it out. You don't know if it will work. You're trying it. If it works, so if for example you say, what do you want to say? Y is equal to float of x.
Float of x.
So basically you're trying it out, because what happens if this is a string, then this will fail. So if this was, let's say x was hello, then this float x will fail. In that, so what we have to do, then next one you say except.
Except?
Yeah, you have to do an indent, because this is the same line, colon, colon, and then here what happens if it's a fail. So exception means it has not worked, right? So you just say return, I don't know, 0.0.
Yeah, so I can just say y is equal to 0.
Actually specify 0.0 just to be on the safe side.
Yes, I see, you're right.
And then
finally return y.
Yeah.
Or we can just say return here itself. So we don't.
Oh no, that's okay. Try is okay. That's better to put try. The try block is better not to do a return. So.
Okay, that's right.
Okay. Yeah. So now that we have this, all you have to do is just apply this on that column.
So this will be S D. No, S. What is that?
You can do tab. Should work.
Yeah. SW. Yeah. I just tab, but I was wrong. Okay. So this will be then apply.
Yeah.
Apply, and then we say str to float.
Yeah.
Okay, and that's it.
That's it. So this now it will return something else. So now you see it's float 64. So the only thing you have to do is you have to now equate this back to SWT top, because this returns another series. So you just have to say whatever this is equal to SWT top.
This one.
Yeah.
Right.
That's it.
Okay.
So now if you look at
see info, I guess. Yeah, all of them are float 64.
Okay. So then you just have to now run that command again, test train split, and check. You can just go and enter. You can actually just
redo the y here. I think this one.
Yeah.
No. This is not the entire. Okay. So we'll have to. So for x we have to do this, and then I will rerun this, where I will drop the PV, and then x will become numpy. Now we will do this, run this again. So I will just check. I will create one more. I will check if x train is fine. Yep, looks good. All of them are fine.
Okay, so good. And okay, x train, x test. Okay, so now what we have done is we have now split our data into a training and a testing set, right? So I'll just stop here. Anyone has any doubt about what we did? I think we might have been a little too fast, that's why.
Yes, sir. Text size by 0.1.
The reason is we have very little data. So if you look, we have only 2,700 rows. That is considered to be very, like for example, if you look at most machine learning projects, to be able to train a machine learning model effectively, you need usually millions of data, millions. So what we have here is actually incredibly small. The chances that we'll be able to produce any meaningful machine learning model is actually quite slim. So besides that, if we actually take a huge component for testing, like 0.3 or 0.4, there will be almost nothing for training. So it will make it worse. So this is the reason why we took the smallest possible ratio for the testing. So the idea is 80% of the data is used for training, only 20% is used for testing.
Yeah, so the test size is the ratio of how much of data goes to test data, validation data, whichever.
So basically, yeah. So I think this is a little confusion here. So what happens is like this. when you train a model on a particular data, you should not test it on the same data. The reason is because if you train it on some particular data or particular batch of data, then on that data, the model will behave well because it has been used for training. The proper test of the model is to test it with another batch of data which has not been used in training. So it is like for example, in medical, right? Like when you want to test a vaccine, you have a control group, you have an experimental group. The experimental group are the ones that receive the vaccine. The control group does not receive it, right? So this is how you test the effectiveness of the vaccine. So in the same way, you are training your machine learning model on the experimental group, on the training data set. When you train it, you then apply it on the other data set, that is a control group. So then you see how well it performs. That is the idea.
If I see this point 1, what I assume is that like 1 in 10 total rows will go to the test. As a percentage, if I see that, then I feel that like only one particular data will go to the test and remaining 9 will go for the training. Is it right, or should I need to interpret some other way?
Yeah, that is correct.
Yeah, so technically we have about 29 days of data, 30 days of data. That means about 3 days of data, 2 to 3 days of data will be there in the test.
Yeah.
Okay.
So any other doubt? Okay. So now that we are here, we may not have much time, but I'll get started with the linear regression part, right? So if you go to that page again, okay, actually just first you can import it. That's a good idea. You can import it. Go ahead. sklearn linear model. Import
linear regression. Yeah.
So the way it works is if you just do linear regression and open parenthesis. So do shift tab. No, actually do shift tab. Let's look at the help. So this help will be the same.
Just put it just a second.
Yeah. All right.
Go up because otherwise it won't be seen. Yeah.
So this is exactly what we were getting also. So what happens is this linear regression is a class, right? To get started, we need to create an instance of the class, right? So we are going to call this linear regression. This is a constructor of a class. What we have to say is we have to decide these arguments, right? Now, all these arguments are pretty much okay. Like I said, fit intercept can be true. We don't have to normalize it because we are not dealing with normalized data. We are dealing with actual real world data. Normalized means everything has been brought into the normal curve. No, that's not what we have done. Copy X. I don't know what copy X. Can you have a look at what is copy X in that other one? Yeah. So copy X is X will be copied, otherwise it may be overwritten. We have a copy of it anyway, so it's okay. So that's the main thing. So we copy X, it will copy. So no problem, let it copy. N jobs. What is N jobs? So this is the number of jobs to use for company. Oh, this is like what happens is if you want to do your machine learning model in batches. That is, you want to keep on running, batch 1, batch 2, batch 3, and you want to do like a kind of a convergence. Again, we're not going into that. So if you go up again, scroll up, we can just call this with default parameters, right? And if you assign it to a variable, you have now your linear regression object. So if you just call it PV whatever, or give any name. Okay. So if you check out what PV is, PV.
Oh, sorry.
So this is a linear regression object, right? Now, I think you'll have to go to the actual tab because it is easier to look there. So if you look at the sklearn linear regression tab. So the way what we are going to do is, now we have this thing. If you come down, scroll down a little. Now we have to look at this thing. See, for example, if you see here, there is the fit method. So we have taken our training and our testing, training, that is X train and Y train, right? This is our training set. So this is the input of the training set and that is the output of the training set. What we are going to do is, we are now going to call this fit method with X train and Y train, and we are going to try to find out how that works. That is a linear regression, right? So you can just copy that or whatever you want, however you want to do it. So basically you just have to say like model, you can say PB model. Yeah. So again, X train, Y train, because remember this is our training set. So now what this will go to another variable which is called, let's say, PB model. You can just call anything you want to call it. So
I'm sorry, you want to go, yeah, you want to send it to another variable. Okay.
So let's check out what that is. So this again it is saying linear regression model, but I think it's just, that's just the way it is. So okay, let's go back to the actual, what do you call it, the help of documents. So what we can do is, on this you can look at the different attributes. So for example, you can see here there is the coefficient and there is the intercept. So you can check out in that the coefficient and the intercept. So you can, yeah. So these are our coefficients. So you see this is a linear model where it has given, so it's like y is equal to mx plus c, only we have different x's. So each x has one of its own coefficient. Alright?
Yeah. Yeah.
So this is what we have. So again, stop for a minute. Does anyone have any doubt?
Yeah, sir. I don't know whether it is clear, sir. So I have small doubt that, like, is there any compulsory that, like, we have to keep x as a capital letter?
Oh no, that is totally your choice. I mean, this is like you can even call it like PB train, PB output, PB input, anything you want. Totally up to you.
Yeah. It's just that I copy pasted. I was lazy to copy pasted it from the documentation, so that is the only.
Yeah, because in coding, suppose like I thought it may be different, so that's why I asked.
Where it matters, you know, that is what I said. Where it matters, if you go up to that train test split, for example, if you go up a little. Now, so you see the train test split, right? That function is taking arguments, right? Now, when you give arguments, like we are specifying x and y, those arguments are called positional arguments, right? So, for example, if you go to the help of test train split, so you see that this is, it says star arrays, alright? So, for example, what that means is you are giving, the first thing is arrays which you are specifying as x and y, and then you are specifying options. So it is very important here that the positional arguments, you don't switch it. So for example, don't say y comma x, then your whole thing will get messed up. Secondly, the output of this train test split is again an array, and these the order matters: x train, x test, y train, y test. So if by mistake you say x train, y train, x test, y test, your whole model will be messed up. So this order you have to take into account, which is why I asked him copy paste from that thing, because unnecessarily if we make like a slight mess up, a whole model will be wrong, and then it will take a long time for you to figure out why it was wrong.
Yeah.
So this is our model. Now, I think we should stop here because it's almost 7 p.m. So I'll just stop and let's have maybe like a few minutes of discussion, because
I think we can quickly check the predict also, right?
Yeah, you can
predict because it should not be taking much time. What is that? Y train, right? No, should be X test.
X test, right? Yeah.
X is capital, I think. Yeah. So this is all right for this. Yeah, you just give an X to predict.
Yeah.
So I will just check. Yeah, it should be there. Okay, let me just.
So what you can now do is
predict. Equal to this, and I'll just plot these two.
Yeah.
Together,
Yeah.
Plot dot. Okay, this will be line plot.
Oh, no, just say plot. Just say plt.plot.
Yeah. Yeah. Okay. And then I'll plot the other one also.
Yeah. And you can before the
underscore test.
Yeah, and you can just put above that a figure.fixSize.
Yeah. I think it was something like 12,5, something like that.
Yeah, you can test it.
Yeah, I'll probably make it a bit bigger. 14,5, 14,8, something like that. So that you can see if it is not that bad. Can we make a dotted one? I think you can do for dotted one, something like that. So that will be a bit better. How do you make it dotted?
Okay. You want to, okay. That is line style, I think.
Okay.
You have to Google again, you have to go into the, you can do shift tab.
Okay, that's fine. It's fine. Anyway. So, some days you can see that it's okay, some days it's not okay, but I think it's doing something.
It is doing something. That's the problem. In this kind, because our data is so little, and also linear regression is not what we should be using for something as complicated as PV prediction. So therefore, this is the best we can achieve. But what is important is that the process, which is what I wanted to show you, right? So you can also, if you want, you can plot in a separate one the error. So you can just take y predict minus y test, or y test minus y predict, and copy the whole thing in another one. So this gives you the error.
It is slightly biased, but most it's okay.
Yeah, exactly.
Okay, yeah, it's quite bad, but
yeah,
it's at least it's at least slightly less biased. It's not. I think the bias comes mostly because there are places where it's just getting the zero is a sort of a limiter.
Yeah,
something. But anyway, good. We have done one complete thing at least.
Yeah.
Okay.
Yeah. So again, any questions from anyone?
Yeah, sir.
Yeah, go ahead.
We create an instance to the class and we call it as an object.
No. Can you repeat that again, please?
So we, that we are creating object for a class, right?
Uh-huh.
So now if we see this PLT, so what we call that, since we are creating it for the library, right?
Mm-hmm.
So is there a name for that?
See, it's like, I'll tell you what it is. The thing about Python is, in Python, everything is an object. Everything. So for example, if you come all the way down and just write a is equal to 10, just write. Okay, now E dot, if you do E dot and just do shift tab, you see these are all the methods and attributes with this number. All we have created is an integer, right? Just an integer, not a class, not an object, just an integer. Even then you have all these methods, because in Python any data can be an integer, can be a string, can be a dictionary, can be a list. Everything is an object which has attributes and methods. Similarly, even plot which you are importing, so we are doing matplotlib.pyplot. So basically matplotlib is a package. Within that package there is another package called pyplot, and within that there is another one called plt, right? So within plt you are now accessing all the different methods which are available, where that is plt.plot. plt.plot is a method within plt. Does that answer your question?
Yes, so you're saying that PLT will be the object which can access the all methods available in the particular library, right?
Exactly.
And so now we predicted some data using linear regression. Suppose if you are finding there is some like if we are not satisfied with these results, so how can we go for the next step? So what are the different approaches to nullify this error?
So the first thing is, if you want any decent data, you need more data points. That's the first thing. So if we would like to continue testing out, or rather getting better at this kind of models, the first thing we need to do is we need to go and search for some kind of data set where we have much more data, like hundreds of thousands or so on and so forth, right? So number one. Now let's look at with respect to this. So linear regression, as I said, is one of the simplest machine learning models, because all you're doing is fitting a line. After that, the next one is what is called as deep learning or neural networks. So neural networks means you have a layer of neurons. Each neuron is basically receiving several inputs and produces one output, which is a weighted sum of the inputs. Okay. So in this manner, if you have a layer of neurons, then in that case, when you train them, you have much more degree of freedom in which you can capture output for a given input. So neural networks will be a much more, accurate form. So for example, this method, what they have used is recursive neural networks. Recursive neural networks meaning means that you are training, you are calculating your neurons by a recursive method going back and forth. Does that answer your question?
Yeah, one more thing is we can probably, in the smallest step that we can take is perhaps use some form of a polynomial regression instead of linear regression.
Yes.
So that would mean that we would just use instead of y is equal to ax plus b, it will be y is equal to ax square plus bx plus c, something like that. So we can try that perhaps, and what I would probably do is I will send this Jupyter notebook, and then you can run it and then see if you want to run other parts such as polynomial regression and all that. For this, I think we can just check the scikit-learn toolbox and the methods associated with it, perhaps. I mean, if you want, we can do that in the next session, or I think we can also start a new one if somebody else has something else.
Yeah.
Yeah, I think I'll stop sharing now.
Yeah, I think that's good enough now. Okay, so I think it's almost time, so I would conclude this session unless there is any specific quick doubt with respect to what we did.
Thank you for the session. I found it very informative. I do have a question. It's not related to the session, but I have been looking at using Python power electronics, and my question is directed to that area. And I just want to know, is there some way that you could direct me to where I could learn or see how you can use what you've set up directly from a notebook or from even the terminal instead of having to use the web interface?
Okay. So you cannot use it from a notebook. You cannot use it from a notebook to begin with because there is no integration with Jupyter in Python Power Electronics. There is a command line interface, but the problem with the command line interface is that you would now have to do plotting on your own. You would also have to specify, you have to go through the command line interface. So, unless you are very comfortable with the command line interface and with things like using, Linux or other things like Conda Terminal, I would suggest you stick with the Django version because at least there you have a web interface where you can click on buttons and things like that. But if you're interested, there is a command line that you can download and use. So,
is that available on the website?
Yes, my website itself. So you just have to go to the downloads page, and in the download page there is a separation between web application and command line. So you just look for command line.
Perfect. Thank you very much.
Yeah, but just in case it's not very easy to use, so it does require a certain amount of experience with command line, plotting and everything else.
Okay. Thank you very much. And again, thank you for the session.
Okay, sure. Welcome. Okay, so I guess we will meet next week. Thank you so much for coming. So, see you everyone. Bye-bye.
See you.